Hello there, welcome back to 9-7. This is the final video in AP Calculus AB, and we're going to go ahead and just look at some various integration techniques for about 3 examples here to kind of wrap up the course. All right, so let's go ahead and check these out. Note that there's lots of different types of integration techniques that you can do, and you'll want to try to fit them into something that you can utilize. Now, sometimes it's good to just take a basic approach. So on number 5, note, hey, I have a monomial in the denominator, so can't I go ahead and split this up? And that's what we're going to do. So we have sine of e to the negative 3x power over e to the power of 3x dx minus the integral of e to the x over e to the power of 3x dx. Okay, so now why was this beneficial? Well, if we look at the left side, on the left side, if I treat my interior right here as u, I say, okay, this is u, I have e to the negative 3x, then u prime is going to be negative 3e to the negative 3x. And I notice I have my e to the 3x in the denominator. So if I go ahead, if I bring this up, so I have sine of e to the negative 3x, okay, and I'm going to drop in now my hook, so I have e to the negative 3x dx. Notice the only thing I'm missing is my negative 3, so I'll put in a negative 3 and I'll balance it with a negative 1/3, and hey, we're ready to go ahead and integrate that sine function. Okay, so the integral of sine is negative cosine, so I have a negative 1/3, integral of sine is negative cosine, so that's going to make this a positive 1/3 cosine of e to the negative 3x. Okay, and there's that piece. All right, and then over here on the left-hand side, if I go ahead and just combine these, right, this is the integral of e to the negative 2x dx, and then for my hook, I just need a negative 2. So I have negative 2, okay, and I'll balance it with a negative 1/2, which will make this a positive 1/2. And we get plus 1/2 of e to the negative 2x plus c. That's it. Very, very simple, right? Again, just split the monomial, and then you can go ahead and fit those into just your foundational examples. All right, example 6. Example 6 looks a little, you know what, red. Okay, number 6 looks very, very complicated because there's lots of stuff going on. And then if you just go ahead and look in the middle of the mess, I hope you see here this function. What if I use that as u? Okay, I'm going to go ahead and see. So if u is the natural log of sine of x, let me see if I can count for some of this other stuff with this. So u prime is going to be 1 over the inside, so 1 over sine of x, and then the derivative of the inside is cosine of x. Hey, do you see the sine of x? Do you see the cosine of x, right? So we already have our hook. Okay, so this is the integral of the natural log of sine of x. I'm trying to keep track of my parentheses, okay, times cosine of x over sine of x, right, dx. Okay, so there's our hook right here. Okay, so that's going to go away. All right, and the integral, right, this is just a simple power. So I have the natural log of sine of x, okay, and this quantity, the power is going to raise. So power of 3 divided by 3 plus c, and that is it. Basic, right? Just if you just have to identify, hey, in that parenthesis, that's the u. Okay, what's the derivative of all that junk? Hey, it accounts for this, this, and this. Boom, it's just a simple power rule. All right. Lastly, remember that if you have if you have a square root in your denominator and it doesn't account for arc sine, and you can't go ahead and account for other stuff in your integrand with that radicand, then what we're going to have to do is go ahead and try u substitution. So here, if I treat the radicand as u, so u is equal to x plus 1, and then I solve for x, so u minus 1 is equal to x, and I take the derivative, I get du is equal to dx. This problem becomes very, very simple if we just go ahead and do the substitution. So I know x is u minus 1. X plus 1 is u, so I have the square root of u, and dx is du. So then what I have is the integral of u plus 1 over u to the power of 1/2 du. And now I can go ahead and I can split this up. I have the integral of u to the power of 1/2, right? They reduce, du, plus the integral of u to the negative 1/2 du. And if I integrate this, we get u to the power of 3/2 divided by 3/2 plus u to the power of 1/2 divided by 1/2 plus c. And that's it. Very simple. All we have to do now is just go ahead and go back and make our substitutions. So 2/3, u is x plus 1 to the power of 3/2 plus 2x plus 1 to the power of 1/2 plus c. Simple. U substitution never seems so easy. Hey, that's it. Good luck in your review for your AP Calculus exam. Rewatch the videos. Feel free to get all the help that you need. Study the stuff that you're a little shaky on. And again, remember, study little by little, okay? And you'll be well prepared. Best of luck. Thanks for joining me. Peace.